Hello, this is my Module 2 on mediation and moderation. I'm going to first start it by discussing the similarities and differences between these two types of models, using overall concepts and how they're both analyzed. So first, moderation is when you take a significant relationship between x and y, and then try to see if another predictor, x variable, can be added in to either strengthen or weaken the relationship between the significant relationship between x and y. And mediation is different in that mediation is looking for a causal pathway in which x and y have a significant relationship, but when you add in a mediating predictor variable, x is significant with the mediating predictor, and then the mediating predictor is significant with y. So essentially, x has to look through this predictor to then predict y effectively. Both of these can be analyzed with regression analysis. However, mediation has more tools to confirm and solidify these results via Sobel tests and bootstrap tests. So first, I went over moderation. I have 3 models of moderation. And before I do that, though, I want to go over the general code that I used to create these moderation analyses and these moderation models. So as you can see, I have my x1, and then after that, I have my x2.m, which is my moderator variable. And according to Barron and Kenny in 1986, we are able to cut and round this variable such that whenever a value rounds to 0, we say that the moderator isn't present, and when it's 1, we say it is present. In other words, we are able to create a dichotomous moderator. So as we can see through R, I used a cut function to do just that. After that, I also created 4 Bs, which are our regression weights. I have B0, B1, B2, and B3. B0 and B2 are affected by B0 and B2 affect the intercept of our models, and B1 and B3 affect the slope of our models. So as you can see, I've inputted an equation for y hat using these regression weights, or B coefficients, and our variables. And then we can see that our y1 is simply our y hat plus some error. So for my first one, as I discussed earlier, we need a significant x and y. So I ran, in this case, x3 against y, and found that x3 is significant, so we're justified moving on. So then I ran an analysis of the interaction between x3 and x4, which is our moderator by itself with y, and our x3 by itself with y. And as we can see, when we add our moderator, x3 is not significant, but our moderator is, and our interaction is. And the way this looks, as we can see through our plots, the red and blue solid lines are our AB lines, or our best fit lines. And as we can see, our x3 is not significant anymore with a moderator because we have an intercept of nothing significantly different from 0 and a horizontal line, meaning that the slope of this variable is also 0. However, the blue line indicates that the moderator is present, as opposed to the red line where the moderator equals 0. When the moderator is present, we get a significantly different intercept from 0, and we get an interaction, as we can see from the lines crossing, and this interaction is positive. So when we add the moderator, we have a positive interaction between x3 and y, and significant moderator to x and y. So then I went on and changed the B values to create a second model. And once again, our x5 is significant with y. So then I went ahead and added x5 with our moderator, our x6, and the interaction between x5 and x6. And it's important to note, I just want to note the r squared with and without our moderator. We have a 0.47, or 47% of our explainable variance is just from x5. However, when we include our interaction and our moderator, we have an explainable variance to the amount of 95%. This shows that we have to adhere to our regression assumptions, as we've gone over in Module 1 and in previous regression courses. that when we excluded these relevant variables, they're relevant because they're significant, we lost half of our explainable variance. So I just wanted to note that because it's important to include all relevant variables. And as we can see, they're all significant in this case, even our intercept. And when we plot them, we have a very, very large interaction. I couldn't quite get the graph to fit out the whole thing. We can see that both of our intercepts are significantly different from 0. They both have a positive slope, and they interact, they intersect. However, it's important to note, though, that the blue line, the one which has our moderator present, it has a steeper slope, indicating that there is a greater effect, a greater positive effect on the model when the moderator is present. So I wanted to create a final model 3, which was our x1, and our x2 being our moderator. So again, our x1 is significant with y. And then for when I included the interaction between x1 and x2 and our x2, we find that our x1 is significant, our x2 is significant, and our intercept and interaction are not significantly different from 0. So what does this mean? When we plot it, we find that, as we showed when our interaction was not significant, the lines do not cross at any point. They have the same slope, and they both have significantly different intercepts from 0, but they're slightly different. In fact, the one thing we can kind of interpret is when the moderator is present, our intercept is slightly higher than when it isn't. And that's about all we can deduce. And this is important to include. I wanted to include this because it shows that if we think we have a moderator, it's always important to run diagnostics and test, because even if something really seems like it moderates, when we plot it, when we go through the diagnostics, we can see that it's not. Then I want to do mediation. So with a mediation model, our Kenny 2018, the Kenny website, I took these models straight from it. These models delineate the process of mediation and the 4 steps involved with mediation, which are also defined within Barron and Kenny 86 as well. So our first step is we have to find that x is significant with y, just like with moderation. And this is represented by our c. And then with our steps 2, 3, and 4, we have to figure out the amount of significance of our c prime, which is our new x and y relationship, when we have a mediating variable. So as a result, we possibly have a causal pathway from A, B to Y instead of just with C or C prime. So I ran my first model, and so first I did step 1. I found that x and y, and x was significant in predicting y. Then I did x and m, and found that x significantly predicts m, which is important because when I ran them both together against y, only m was significant. This indicates that A is significant if we go from the last model. B is significant, C is significant, but in this case, C prime is not significant, which could indicate very close to full mediation. And I'm going to show you how I know this right now through the use of a bootstrap test. As Hayes and Preacher indicate about bootstrap tests, especially when you have low sample sizes, they are better at solidifying your mediation results through regression than other tests such as Sobel, which are prone to the effects of underpowering. And so what the bootstrap test does is it randomly samples, but also has replacement. So essentially what happens is it randomly samples and replaces whole time our n, and then it does that however many simulations we delineate that we want it to do. So it randomly samples from our sample size of 500 1,000 times in this case. And as we can see, it spit back out ACME, ADE, total effect, and prop mediated. So what this means is our ME is our mediated effect, our ADE is our direct effect, and our total effect is our C. And if we want to speak further in those terms, our ADE is our C prime, And our mediated effect is essentially our A and B. And in this case, our A and B are significant, our C prime is not, and our C is significant, just like we found with our regression analysis. This is further important because all the estimates that this bootstrap produced are equivalent to the coefficient estimates that were given to us from our regression. So for our C, when we just did X against Y, we did have an estimate of 1.08, as we can see up here in the top left. So additionally, the fact that this is significant displays that we cannot rule out mediation. And in this case, prop mediated indicates that our model is mediated 98 has 98% mediated by our mediator variable, which is very close to full mediation. And as we can see from our plot, our ADE is not significant against 0, and the others are. They're around 1. So when we run a second model where we change the parameters around a little bit, our X now is an estimate of 2.01, and it is significant with Y. Our X is also significant with M, just like last time, so we have a significant A and a significant C. And however, with this model, if we look on this bottom chart here, we see that we have a significant C prime and a significant A and B path. So what does this mean? So when we throw it into our bootstrap analysis, just like before, we find that they're all significant. And when we look at our prop mediated, we have about a 0.5, which indicates that if the term existed, we have perfect partial mediation. This model, this mediator variable mediates roughly half of our model. So we therefore cannot rule out the presence of mediation. There's enough evidence to suggest that to some extent our model is being mediated. Our X and Y is being mediated. And specifically though, we still have a significant C prime. And to further illustrate the amount of mediation we have, we can also consider the tau equation. The tau equation is that tau equals C minus C prime. So in effect, the closer that tau gets to C, the more mediation the model has. And in this case, with half being mediated, our tau is roughly half of C. So we have evidence of partial mediation. Additionally, if we look back at our first model, we can see that our tau is extremely close to C because the proportion mediated is 0.98. So with tau in this example, we would subtract our total effect, our 1.07, from our ADE, and we would get our ACME. And our ACME, as you can see, is very close to our total effect, or C value. And that's why we have a very high proportion of mediation. Thank you.